mine, yeah, but I'll do like a minute, so... Izvini, jel možemo provjeriti ovo, jel trebam da kliknem nešto ili... Radi, okay. He says it's working, so he needs to. Yeah. Okay, good morning everyone. Hope you had proper sleep. And yesterday was all about Web3 and crypto, and today we're shifting to more like traditional finance. And our first keynote speaker joins us from Canada. Professor Seco is the Director of Mathematical Finance Program, Profession of Mathematics at the University of Toronto, and Director of Risk Lab, a university research laboratory established in 1996, conducting research in quantitative finance with special focus on asset management. His current activity is focused on sustainability, including climate risk, and is simultaneously the chair of the Center for Sustainable Development at the Fields Institute and affiliate faculty member at the Vector Institute for Research in Machine Learning. Professor Seco's core activity is bringing artificial intelligence into today's sustainability challenges to build a new, better world for the future. He also authored papers in artificial intelligence and environmental scores, and is currently expanding that work to analyze CO2 emissions and carbon trades using machine learning. The title of his presentation today is The Dawn of the Social Fintech, AI, Sustainability, and Social Science. Thanks for joining us.
We live in very interesting times, and my talk today is going to be a reflection on many of the conversations that I have with my friends and colleagues, especially in the humanities. I suspect most of you come from the sciences, and many people still believe that there is an intellectual divide between science and the humanities. Especially the people in the humanities, they continue to think like probably 500 years ago, that there's the humanities on the one hand and the arts, and then the sciences on the other part. I've been saying for a long time that that division is no longer working. It's old. It isn't like that. And artificial intelligence and data science is precisely the reason why these two disciplines, or these two bodies of knowledge are getting together. I'm not very popular when I say that, especially my friends in the humanities. They don't agree. They continue to have a certain perspective on intellectuality, and my friends in the sciences don't agree with me either. So I find myself sometimes very lonely in my position, in my philosophical position as to what intellectual innovation is these days. So that's going to drive me, but this is not a talk about opinions. I'm going to focus on facts, things that I have done. And maybe by the end of it, I'll convince you that, if you were not already convinced, that things are different to the point that what we call knowledge has actually changed. And for that, I want to start with a very simple reflection, which is how innovation has evolved by comparing the 20th century and the 21st century. The 20th century, engineering, if you want, would be perhaps summarized by this picture. I like to ask people, what do they consider to be the biggest achievement of the 20th century when it comes to engineering? And there's a variety of opinions, but I like to use this as an example. And if you reflect on what this was a remarkable achievement that consumed no data, gravitational constant, the size of the Earth, distance to the moon, and that's it. Okay? 3 data points. And then you had lots of equations. And the equations, you solve them to remarkable accuracy, and then the result is something which is, it relates you to the physical environment. So a lot of the innovation in the 20th century was subject to these 3 observations. No data, or small data, lots and lots of equations, and the impact is something you can see, feel, touch, smell, eat, even. Okay. Now, when you come to the 21st century, things are a little bit different. First of all, we have lots of data, and I like to exaggerate, I already told you. No equations, and everything happens in a mental space. We cannot see it, we cannot feel it, we cannot smell it, we cannot eat it. And that's where innovation happens. And this radical change makes people confused. But that's what it is. This is what we're dealing with. Now, I want to compare my first paper in mathematical finance from 1996, which is this one. And in this one, I had no data. I had lots of equations. And it was in a mental environment. I didn't send anybody to the moon. What I did is I just created a framework for doing risk calculations, financial risk calculations. And I've been doing these kinds of things for a long, long time. This was from 1996. There was no real data science back then. There was no real artificial intelligence back then. But I want to share something personal with you, which is one of the activities that changed my professional activity. And it happened during the pandemic. I have here a picture of the Premier of the province of Ontario, who in the province of Ontario is the province where Toronto is. It's a province in Canada. In Canada, health is a provincial matter, and the provinces are the ones who dictated the confinement measures, the stay-at-home measures, and all of that. The Premier of the province is this one here, Doug Ford, who every Thursday at 2 p.m. Did a press conference to explain the COVID situation. What he's holding in his hand is a graph, which was part of a routine submission that we did to the province every Wednesday in preparation for the Thursday event. We've been submitting this for a year, and then suddenly one day he holds one of those reports in his hand and shows it to the press group. They took a picture, they published it, and now I use it to explain something which I consider to be very relevant. This is one of our estimates of the caseload projections if certain measures were to be taken into account, and also a projection for the impact on the economy. Our job, I'm not an epidemiologist, I understand finance, and my job was to focus on the impact on the economy of the different confinement measures. And this picture summarizes much of what I believe, which is that public policy is not going to be unaffected. It is going to be affected by data science and everything that we can do. In this particular case, we had a large data set. We had no equations. We had no equations. No one understands how the virus moves, but we were dealing with a physical environment. And this transition of 25 years is, for me, a very good summary and a personal reflection on what matters in the way we do things. So today I'm going to present some of this journey and some of the results that I've taken, but I want to put it in the context of something else that happened. My talk is a little bit historical. Now I go back to the year 1990 when something very interesting happened. This was a year in which the Harvard University Endowment Fund made a shocking decision. The shocking decision was that they were going to divest from tobacco stocks. For those of you who are old enough, in the year 1990, when you talk about divestment, people were talking about South Africa and apartheid. No one was talking about tobacco stocks. So why would Harvard University decide to not invest in tobacco stocks? It's a very interesting context, and I like to, when I teach courses to my students, I like to put this as an example of something that was done for social reasons. They, as you know, the tobacco companies started to get sued shortly after this for essentially killing their customers. And the tobacco industry became an industry to avoid if you were a long long-term investor. And of course, endowment funds are very long-term investors. 30 years is nothing to them. So I like this as an example of what I would call the social fintech, which is something which will be, sorry, there we go, okay. I want to fast forward to today, and today you can do incredible things using large language models. I have an example here. This example is due to the company of one of my graduate students. The company is called Responsibly. And what this company can do is you give it you give it a stock name, okay, or a security that you are either thinking of investing or you're already invested, and you establish the criteria, the social criteria on that company. You want to know their HR issues. You want to know their environmental impact. You want to know their governance qualities, you name it. And then through a large language model, you can get this analysis over time of the different qualities of that company. This is remarkable. This is a remarkable picture because it shows a different way of consuming data to make investment decisions. In other words, what Harvard University made, the decision that Harvard University made in 1990, which was very much talked about, is something that portfolio managers now do on an hourly basis. And to have aids that help you do that is critical to the investment process. So investing has changed. Investing has changed. I'm going to explain this I want to look at the 100 years of investment evolution by looking at the data input. I like to understand businesses looking at their data consumption. And if you look at how investing was done 100 years ago, that was when value investing started. And the data consumption back then was company accounting information. You could write the data with a pencil in a piece of paper. But this was a remarkable discovery. And a footnote, this was based on the fact that accounting was finally established. Okay, this would have been impossible 300 years ago because there were no accounting standards. You could easily deceive people with wrong financial data. Here we had accounting standards. It's very important to note this was after the crash of 1929, which is when regulation made it more difficult to deceive people and to deceive markets. So that's when value investing started. I'm not talking about regulation, although it's a very, very important discussion. And then 20 years later, more or less at the time that computers were created, we started to have what we today call portfolio theory. Now, I like to remind people that portfolio theory, maybe it could have been invented 50 or 100 years before, but it would have made no difference because you had no way of implementing any of that. The only thing that you could implement, the only implementable financial decision was to do value investing because you didn't have the ability to deal with data. But now with computers were invented in the 50s, you could start to deal with time series for the first time. And this really was what opened up the portfolio theory that some of you may have studied or you may have used. And many, many people in the financial industry are still thinking from the philosophy approach of 1950, which is time series and numerical databases is what matters. We're still acting as if the computer had just been invented. Of course, that's not the case. We have lived about 50 years where investment decisions have been made thanks to the computer and dealing with what computers have been doing for the last 50 years, which is deal with numerical data. But now things are different. Just go. There you go. Yeah, things are different now because databases are changing. Bloomberg is no longer the only source of financial information. And what I just showed you that my graduate student does in his company is an example of that. If you want to understand a company's social values, for example, tobacco stocks in the 1990s, what data would you use? Would you use Bloomberg data? No, the relevant data is going to be on the internet, on disclosure statements, on audit reports, and so on and so forth. That is the radical change that we have seen from the data perspective. And see, the change from 1930 to 1950 is comparable to the change from the year 2000 to the year 2020. The data that we consume now is completely different. I like to use an example here, which is GameStop. You know GameStop, the company GameStop? Yeah, you know what happened with GameStop? The young people know. Okay. Yes. So the important part of what happened to GameStop, and I like to ask people, is what is the relevant database to understand what happened to GameStop? It's not Bloomberg, it's Reddit, right? So if you wanted to do a trade, if you wanted to trade GameStop in real time, Bloomberg was useless to you. Bloomberg will tell you what happened a few hours ago, right? So that is a very good example on the new paradigm that we're dealing with. Now, this is not something which is going to be, I'm going to not focus on GameStop. I do want to focus on what I call the social fintech, which is the financial technologies in the context of social elements. But GameStop is a very good example of what I'm talking about. In a certain sense, GameStop is the tobacco company decision of Harvard University made today, but not made by a $35 billion endowment fund, rather made by 35 billion people with $1, which of course has the same impact on the volume. Okay, so that's more of what I'm talking about. And to understand this, I want to dissect data into what is the traditional source of data, which is numerical data, numbers. So many people still think of databases as collections of numbers. That is from 1950, okay? And maybe in the year 2000, you can say that was still the case, yes. But we're no longer there. Textual data is just as important. In fact, I would argue, and as by now you know I like to exaggerate to make my point, that if you really want to do proper investing right now, you better know how to analyze textual databases. The GameStop example is not an exception. It's happening everywhere. I'm not touching on this today, but just to give you an idea, they say, I haven't done these numbers myself, but that the flows that originate from social trends are of the order of $40 trillion. That's bigger than the US economy. So if you do not take into account textual data, you're not going to be doing well. Well, I can talk about more about that if you're interested. But now we are moving very quickly into a new type of databases, which is sensor data. We are creating very fast databases of sensor data, which will be harnessed at some point. We're not ready for this. I don't know anybody who is actually doing this today, but it's coming, and it'll be happening very, very soon. And we're in a data science conference, so this has to be mentioned. Okay, and that will soon be followed by images, satellite input, video, and who knows what else. So this data revolution that we're dealing with is changing the way investing happens, is changing the way financial decisions are made, and what in 1990 was an exception is happening now on a daily basis. That's what's happening, okay? So I want to now fast forward and tell you what's happening with financial markets today and talk about some of the new financial markets, which is how I will define my social fintech. I have here a screenshot of it's a screen that when I didn't fly from Canada directly here. I came from China. I was in Shanghai on Monday. But if I had come to Belgrade from Canada directly, if I buy my ticket online from the Air Canada website, I would have found something like this. Maybe some of you have done this. When you fly an airplane now, you are able to make your trip carbon neutral. Has anybody done that? Do you do that? I do that. The university actually not only allows us to do that, the university also will charge us an additional tax. So I get to be carbon negative every time I fly. Okay. So do you know how this works? This is very interesting. So let's reflect on this a little bit. Okay. If you don't know how this works, then I think you'll learn something very interesting. When you fly, you go a certain distance, there is a way to know what your carbon footprint is. In other words, there is an algorithm, it's very important, there is an algorithm that says, depending on you fly economy class, business class, premium economy, we know very well how much, how many tons of CO2 a flight from A to B produces, and then you get a share of that. Okay? Let me come back to this in a minute. So that's your share. I think coming to Belgrade, I'm going to guess it's 2 tons of CO2, maybe. That's what I would produce if I come here, okay? 2 tons of CO2. And then CO2 has a price, which is about, depends on where in the country, where in the world you are, it ranges from $10 to $30 or $50. Let's say $10, because it's easy to multiply by 10. So if my footprint is 2 tons of CO2, then 2 tons of CO2 is that means you're burning 2,000 liters of gasoline. That's my it's a bit more, because when you burn gasoline, about half of it becomes CO2, right? So that would be, let's say that's my share. And then if the price of a ton of CO2 is $10, that's $20. So I pay $20 and then I become carbon neutral. That's how it works. So how come that me, do you know how this works? I'm looking at faces and I need to read my audience. Who knows how this works? Raise your hand. Okay, then I'll ask one person. So who does not know how this works? Raise your hand. Okay, you're a very good audience, because there's some of it. Everybody raise their hand at some point. Good. If you don't know how this works, then let me spend a minute on this. This is very interesting. Let me go through it. First, someone has to calculate my carbon output. I go the plane takes off, the plane is burning fuel, and some of that fuel becomes CO2. That's not so hard. But then how do they apportion that to me based on which section of the airplane am I sitting? Who is doing that? Who is doing that? Consulting companies are doing this, right? Because the same companies that do financial audit statements to banks. That's the business. That's the new business. That's the new audit business, right? Of course, no one is going to go to jail because you miscalculated your carbon output. At least not yet, right? But there is. I said that in 21st century there are no formulas. Well, is that a formula? It actually isn't really a formula, because no one really knows. It's not like you plug this, you take the square root, and that's your carbon footprint. No. They've done studies, they've used data, and then there's a rule of thumb, which is, I guess, a human analog of a neural network. That's it. It's a neural network you can do with pencil and paper, done by a consulting company. PwC will do this. Okay, a neural network with pencil and paper. Let's say that's what that calculation is. Yes? I want you to see the future, okay? And we're going to follow this example. And then I would go there. I say, well, for $20, I'll make my trip carbon neutral. And I pay the $20. And I pay the $20 to who? It's a very good question. Who gets the $20? Well, there's a company here, it's called Choose. They get the $20. Okay, and that allows me to say that my trip is carbon neutral. Is it really? What do they do with the $20? All right, so what they do with the $20 is there actually is a market for carbon. Someone goes and says, give me the $20 because with the $20, I will remove 2 tons of CO2 from the atmosphere. Okay? Okay, who removes 2 tons of CO2 from the atmosphere? No, that's not true. Let's say that let's say I buy a piece of land out there and I plant a number of trees, and then again, there's another consulting company that will say, if you plant this type of trees, mahogany, for example, is very efficient in carbon capture, okay? Or mangroves are extremely efficient in carbon capture, and then after a period of time, I've removed so many tons of CO2 from the atmosphere. Therefore, if I invest this money in this land development project, then I get that credit of the carbon I have removed. Who validates that? The same consulting company, right? Now, what if you get it wrong? What happens if you get wrong the valuation of JP Morgan earnings statement? What happened to Anderson? Remember Anderson Consulting? They're the one who did the accounting for Enron. What happened to them? Right? Okay, well, we're not there yet, but we're coming to that. But you understand, now, what formula goes into the calculation of my carbon capture if I plant a forest? In the airline, we have an idea. We know how much fuel was burned, and you can do some calculations, and then you divide, and then that's about right. What if I do a forest? Who calculates that? It's fantastic, because no one really knows, right? No one really knows. But there are formulas, and I teach a course on carbon trading. It's fantastic, because the input that you have for a carbon trade, for a forest, is how many leaves are in the forest? How can I know how many leaves are in the forest? Is that very hard to do? It's very easy to do. Fly a drone, do some statistical analysis, and you got it, right? Okay. But of course, not all leaves do photosynthesis the same way. Again, some trees, like a pine tree, for example, has a less carbon capture than a mahogany tree, for example, right? But then people have been doing these things, and there is some idea of how that works, right? And that's the market that exists. How big is this market? Sorry? Too big. No, not big enough. It's going to be maybe 10 times, maybe 100 times the size it is now. And this is at a time when governments are not really getting serious about their carbon neutrality objectives, okay? By the way, one of the countries that's taking this most seriously is China, despite what people believe, okay? And I'm going on the record saying this. I just came from there. But you understand, this is fantastic stuff, because if you now take this in the financial context, we're talking about a market. What's the size of this market? You can say, well, I'm paying $2,000 for my flight, and $20 goes into carbon capture. So it looks like it's 1% of the real deal. But no, it's not. No, it's not, because these things are going to grow. These things are growing. These things is not only affecting airplane flights, it's affecting buildings. What's the carbon capture? Oh, sorry, the carbon footprint of a building like this? I doubt someone knows, but very soon we will have to know. And carbon accounting will have to be there. And I just said the word accounting, which is a word that I said about 10 minutes ago, 15 minutes ago, when I talked about value investing in 1930. value investing in 1930 would have been impossible without proper accounting. So now we're in an era where these trades are happening and we don't have proper accounting. And we will have to have proper accounting. And guess what? The accounting will have to be such that if someone lies, goes to jail. Now, this looks like science fiction, doesn't it? That I would be able to do carbon accounting for a building, for a forest, or for an airplane. In a way that whoever does the accounting takes the liability of punishment if they do it wrong. And this is happening. This is going to happen. Don't think this will happen, right? And who's going to do it? The people in this conference are the only ones equipped to actually doing this. And what's the size of this market? I just told you it's about $40 trillion and growing. That's the business. That's the business which is about to be created. And the people that will be running this business are the people in this conference. Yes? So I don't know what job you're doing. Quit it and take this one. Okay? Well, don't quit it. You know, be ready for this because this is coming. This is coming. All right? Okay, let me continue a little bit. And let me tell you about trading. I don't know how much you know about trading. But let me tell you about trading because, and I like to call it risk trading. Why? Every century has their commodity. What's the commodity of the 20th century? I would say gold. What's the commodity of the 19th century? Could be coal. I would say wheat. Okay? Doesn't matter. You could argue that the commodity of the 20th century would be oil. Okay? But what's the commodity of the 17th century? That's the most interesting one. Rice. In fact, rice had the first organized exchange ever. It was in the year 1697 in Osaka. And that was fantastic because it allowed producers and consumers of rice to lock in the price for rice. And that, as you know, that decreases your uncertainty, it decreases risk, it decreases volatility, and makes the market to be trustworthy. Okay? I call it risk because it does do that. I transfer my risk to you, and you as a producer transfer your risk to me. And between the two of us, we reduce the risk, and we both win. That's why exchanges are so useful. Now, the first example I have of that is in the year 1750 BC, and it appears in the Code of Hammurabi. This is the first documented, that I know, example of risk trading. And it was the beginning of the insurance sector. It was a fantastic discovery. If you were a shipping company, then you ship things with you, and then if you have an accident at sea, and you lose all the stuff that you're carrying, what happens to you? There were no companies, there were no concept of limited liability corporations. Well, you're done. I mean, everything you own, including your family, belongs to someone else, right? And they will take everything, including your life, until they recover what you lost at sea. And in the Code of Hammurabi, it was recognized for the first time an insurance contract where someone would sell you the protection for that trip. Okay, let me fast forward. Then you have the CME, Chicago, 19th century. And today, what we have is Article 2.1c in the Paris Accord that it's there. But basically it says what I just explained to you, that in the quest to eliminate or decrease climate risk, the financial sector will be the one to make it happen. In other words, you're going to attach dollars to this, just as I explained to you. And 193 countries signed that. This is going to happen. We don't exactly know how, but we just got a glimpse that if that's going to happen, it will have to happen our way. the way that we are talking at this conference. Right? I'll leave you with that thought. Let me continue now, and so you understand how interesting trading is. I have here a little game. I have a game one. I give you two choices. In choice A, you're going to make $900 for sure. And in choice B, there's a 90% chance you make $1,000 and a 10% chance you make nothing. Can I have a very quick show of hands? Who picks A? Okay, who picks B? Okay, there's always 10% of the people who pick B. It's very important, very important. Let me give you a different game. 100% chance you lose $900, and 90% chance you lose 1,000, 0% chance, sorry, 10% chance you lose nothing. Who chooses A? 10% of the people choose A, 90% will choose B. So this exactly is reversed. Why? Well, I don't, yes. The thing is that our brain is not symmetric. By the way, this is the human brain. A neural network will make a completely different choice, okay? Our brain is a very good risk management machine. We hate risk, okay? Now, I'm not gonna get into the psychology of this, but what's happening here is very interesting because I know your answers. I told you, 90%. So if I know your answers, why don't I become a broker, okay? I modify the numbers a little bit, so I make a 1% commission, and then the ones who want A, I give you A on the other side, and then I stop. Then everybody's trading with each other. You're all very happy, and I'm the broker of this, and I keep on making money every time someone trades. That's why trading happens, right? And this is how social trading will happen, and this is how carbon credits will occur. So if you were thinking of changing jobs earlier, no, change into this one. And by the way, for a carbon trade, the commission is 50%, not 1%, 50%. That's a different story. I'll tell you, next, no. Well, you want to know, you contact me, I'll tell you, okay? Now, this is interesting because let me bring this closer to home now. And when it comes to climate risk is actually a very simple risk. If I compare this to COVID-19, for example, which is the fact that it is a risk that depends on a single factor, emissions. For a risk manager, this is like heaven, this is wonderful. It's only a single risk factor, very easy. But let me not get into that. If it's emissions, let's study emissions. And this is something which is very often presented as the emissions chart. People look at countries and their emissions. And I have one chart that is typically used. And they say, oh, China is the biggest producer of CO2 emissions. It's right there. 10 gigatons or something per year, right? But then there's some people say, well, wait a minute, this is not right because you should divide by the population and then this should be the proportion. And then China disappears and then suddenly Canada comes up. Now let me ask you a question. Which table is right, the one on the right or the one on the left? The thing is that neither of them is right. Of course, see, they're numbers, and I can divide something by something, and the result is a number, okay? But the fact that I put it as a beautiful table does not make them significant at all, right? And this is one of the problems that we have now, talking about maybe the problem of artificial intelligence, or actually the problem of computing, which is that people tend to believe what comes out of the computer because the computer never makes mistakes. Yes, for sure, this table is probably correct, but it has no meaning. Either of those two tables have no meaning. Why? Why is dividing CO2 by the number of people relevant? People who do, anybody does physics here? You are physicists? Physicists know this very well, right? Yeah, physicists know this very well. They know that units matter, right? You divide meters by meters, yeah, that makes sense. You divide meters by seconds, well, that's meters per second. Be careful there because now you just invented a unit. Is it useful? We don't know. So these are units that people create every day not knowing whether they mean anything. Okay, and they actually don't. They actually don't. So I want to end with something. I have 2 minutes left. I want to end with an application of not only data, not only artificial intelligence, but I guess you need common sense, which is this. If we want to do proper climate risk policies, then we need to know what is the appropriate, not footprint, we already talked about that, but benchmarking, which is a building like this, how much should it produce in terms of CO2? Or a country like China or Serbia, how much should they produce in terms of CO2 so that we can actually measure progression against the Paris Accord objectives? And believe me, dividing by the number of people or dividing by GDP or dividing by any number is not the way to go. We need to understand what's the real relevance of these things. So what drives emissions? We need to know that. And how to benchmark that by country, by province, by city, by building, by air flight, right? And so I'll just show you something that we did. It's emission feature engineering. So we saw that of the different features that a country has, some contribute more than others. Therefore, it's not dividing by a number that matters. You have to do a slightly more complicated fit of emissions to the parameters of that country or building or flight. And only then you'll understand if a country is in green or brown. Okay, and I will end with this chart, which I like. It's some countries, 16 countries. And when you do the proper calculation of their emission footprint, then you see if they're brown or green. We have this example here of a country that's getting browner and browner. I think I made the color wrong. It's just increasing their emissions. And this one that is decreasing the emissions. But this is with the right benchmark, not just dividing something by something, okay? And of course, no one is going to go to jail for making a calculation which is wrong in this context, but we are converging to something like this. And very soon, these things, I mean, our life will depend on it, and we better have good ways of doing that. And trading, as we saw earlier, is going to make it happen. And everything that's been discussed in this conference will find some room to make a system like this work. Thank you very much.
We have some time for questions.
Thank you very much. Do you think in the same way some other pollutants could be in the future used? In terms of CO2 is one of the most, I would say, popular so far. But now as the science in terms of climate change and air pollution and in general pollution let's say, develops, there are many interesting facts that come up. So is it our future?
Well, the future is going to be in accounting for sure. The future is going to be accounting. Now, when it comes to climate risk, I don't know how much of this you know. CO2 is the there are there are 7 greenhouse gases. Okay, the most the most potent is actually water, but we don't care for water because it rains and then it goes away. Okay, CO2 stays there. It stays there for 1,000 years. It doesn't go away. So we worry about that because it does have that. Methane, for example, is 80 times more potent than CO2, but it gets oxided after 10, 20 years, and then it disappears, becomes CO2. So we're less worried about that, although it's much more. There's a whole, we've managed to eliminate the hydrofluorocarbons, which is good. Those are gone. And it's one of the 6, they're gone. And by the way, that's why no one talks about the ozone layer anymore. It's coming back, right? It's coming back. So we're dealing with that today. Okay, like 20 years ago, we talked about hydrofluorocarbons. They're gone. No one talks about that anymore. Now we talk about CO2. In a few years, maybe it's mercury or something. We don't know, but we are now equipped to knowing these things. 100 years ago, you couldn't do this. Okay, even if you knew that all this measuring was difficult and making any, but now we can measure and we can. Data is actually our salvation to do proper accounting. Okay, we're at the beginning of it. But it's going to get fantastic. And people will trade this, and they will be and everything on a blockchain, for sure. Yeah, thank you.
Thank you very much for a very inspiring presentation, and hopefully someone builds a startup.
Thank you.